once again we see our basic little inverting amplifier here, and we're going to beat this sucker to death. Now, this acts as a voltage controlled current source where the load itself is the feedback element. Now note, the load may not be just a simple resistor. It might be something considerably more complicated. There is one restriction on the nature of that load, however, which we'll get to in a few moments. But as we saw earlier, since we've got a virtual ground at the inverting input, the current through R1 is fixed, VI over R1, and since it can't go into the inverting input, then it all has to go through the load. So I sub L, the current through that load, is simply VI over R1, and thus you have a current through the load which is dependent only on V sub I and of course R1. In this configuration, this is considered to have what is called a floating load. The load itself is not connected to ground. It is not connected to the power supply. It's not connected to anything. You may have a bunch of stuff in that little box labeled load, but it is completely self-contained. If it's somewhere or other connected to the circuit ground or the circuit power supplies or anything else, then the current I sub L will indeed enter the terminal on the left, but the current leaving it is going to be something else almost certainly, because some of the current is going to enter or leave through the ground terminal of the power supply terminals. So in a situation like this with a floating load, you cannot have connections to other parts of the circuit. It's got to be a self-contained load. That's the one restriction on here. In our next video, we'll see how to overcome this so you can actually have a grounded load and you've only got a single input where you're defining the current into the device. By convention, this is called an inverting voltage controlled current source, simply to reflect the nature of the circuit, which is your basic inverting amplifier. We can do a similar thing with the non-inverting amplifier and make exactly the same sort of argument, where I sub L is dependent only on V sub N. We've got a virtual V sub N, as it were, at the inverting input. Thus the current going to the left through R is simply Vn divided by R, and that current all has to go through the load. Once again, that load is a floating load. You cannot have a connection to ground inside the load or a connection to the power supplies or anything like that. It's got to be a self-contained floating load. But this does allow you to make a voltage-controlled current source. In order to have a grounded load voltage-controlled current source, the circuit becomes a little bit more complicated and the analysis is a little bit more complicated. And so we will see that in the next video.